Welcome back. In today's lesson, we're diving into the fascinating world of neural networks and deep learning. These are essential components of modern AI that help solve complex problems like image recognition, language translation, and more. Let's break down how they work and why they're so powerful. Neural networks are inspired by the human brain and consist of layers of nodes, or neurons, that work together to process information and make decisions. Deep learning, a subset of machine learning, builds on these neural networks to solve even more complex problems. Let's start by understanding the basic structure of a neural network. At its core, a neural network is made up of three types of layers: the input layer, hidden layers, and the output layer. The input layer is where the data enters the network. Each node in this layer represents a feature from the input data, such as pixel values in an image or words in a sentence. Next, we have the hidden layers. These are the layers between the input and output, and this is where the magic happens. Each node in a hidden layer processes the input and passes it on to the next layer. The more hidden layers we have, the deeper the network becomes, which brings us to deep learning. The output layer produces the result, whether it's classifying an image, predicting a value, or making a decision based on the data that is passed through the network. Let's take a closer look at how data flows through a neural network. When data enters the input layer, it's assigned a value to each node. These values are then passed to the hidden layers, where they are transformed by mathematical functions and weighted connections between the nodes. This transformation helps the network identify patterns and make decisions. The nodes in the hidden layers use activation functions, like the sigmoid function or ReLU, to decide whether the information should pass to the next layer. These functions help the network learn complex patterns and nonlinear relationships in the data. Now, let's talk about deep learning, which uses deep neural networks to solve much more complex problems. While traditional neural networks might have one or two hidden layers, deep neural networks have many, sometimes hundreds of layers. By having more layers, deep neural networks can learn to recognize more intricate patterns. This is what makes deep learning so powerful, especially for tasks like image recognition, speech recognition, and natural language processing. More layers mean more capacity to learn from complex data and improve performance. Let's look at a practical example of how a deep learning model works: image classification. In this example, the model is trained to classify images of animals, specifically whether the image is a cat or a dog. The model takes the image as input, passes it through multiple hidden layers, and finally outputs the prediction: cat or dog. During training, the model learns from labeled images of cats and dogs. It adjusts the weights and biases in the network based on the feedback it receives. This is done using a process called backpropagation. Over time, the model gets better at recognizing cats and dogs, even in images it has never seen before. Once trained, the deep learning model can correctly classify new images it has never encountered, making it incredibly useful for real-world applications like self-driving cars, security systems, and even medical imaging. And that concludes our lesson on neural networks and deep learning. We've explored the structure of neural networks, how they learn, and how deep learning models can solve complex problems. In the next lesson, we'll continue exploring the world of AI by looking at how models are trained using real-world data. Be sure to subscribe to Gift Tech Solutions for more insights into AI, and stay tuned for our next lesson.